So I'm going to talk about routing failures in Lightning. So basically, Lightning is a network of payment channels, and you can pay anyone you can find a route to. And in routing in Lightning, you have two completely different concepts. How to find a route, pathfinding, and once you have a route, how to actually send a payment through the route to the final destination. This is what Christian showed. That's the source routing. So it's two different parts. When you have the graph, how do you find a route to your destination? This is not part of Lightning. Pathfinding is not defined anywhere in the specs. You do what you want. You can compute the route yourself. You can ask someone to compute the route for you, but it's not specified in the actual Lightning specs. Once you have a route, what is specified is how you create onion messages to get the payments to be forwarded to its destination. So to compute the route, to have a model for this, for the graph that you have, we use a routing table that is made up of gossip messages. And you have three types of gossip messages. You have node announcements. This is a Lightning node. You have channel announcements. This is a Lightning channel. And you have channel updates. And you have one update for each side of every channel. So can you tell me why you need two updates, one for each side? What are these updates used for? Yes, exactly. So if you have a channel between A and B, A will say, okay, if you want to route through me using this channel, this is the fee. These are the fees I'm going to ask you to pay for, and this is the CLTV delta I'm going to ask you to use. And if B wants to if you want to route payments using the same channel but through B, B would say, okay, these are the fees that you need to use, and this is the CLTV delta that you need to use. So A sets routing fees when you want to route through A, and B sets routing fees when you want to route through B. And it's very possible that you can use a channel on one side only. If all the money is on A's side, it won't be possible to use it to route payment through B. And so you won't have a channel updates for this side, or you will have one that is disabled. And the only information you actually need to create onion payments are channel updates. You don't need channel announcements. You don't need node announcements. So this has been shown to you already. When you receive a payment, you peel off your onion layer and it reveals the destination, the next hop, the amount, and the CLTV that you're supposed to use when you forward the payments. So basically you get this. The node that is relaying a payment has an incoming payment, we call it upstream, and an outgoing payment, downstream. And it's relaying payments. It has an amount and an expiry on the upstream side, and on the destination, on the channel that it's supposed to forward the payment to, it has also an amount and an expiry. So why do you think the node in blue could fail to route a payment? What do you think are potential reasons for failing to route payments?
Not enough fees.
Yes, not enough fees.
Invalid figures.
It could be also failures because the node is not available. There's another one.
CLTV too small.
Yes. So.
Onion encryption. Onion encryption.
Yes.
The payment hash is not nice.
So there are also, if you use tricks like the spontaneous payments, invoice payment, it could be that also. So you have plenty of reasons for payments to fail. It could be because the hashes is badly formatted. The onion is unreadable. It could be because you have errors on the upstream channel, like the balance is not enough to move money from one side to the other because there's a problem with the CLTV expiry. it could be because you have problems on the downstream channel, because there are balance issues, not enough money to send to send money on the downstream channel because the number of pending payments or the amount that is locked in pending payments is too high. So these are cause for failures. But it could also be because relay fees are not met, or because the CLTV delta, the time I want to fix problems downstream is too short for me. It could also be because the channel doesn't exist. You are using a routing table that is old, the channel has been closed, but you don't know it, so you're trying to route through something that doesn't exist anymore. Or it could be because the node that you're trying to forward payment to is offline. So you have many different types of errors that will cause your payments to fail. So in the specs, you assign them types, and for certain types that are not fatal errors, for errors where you can actually retry, when you return errors, you can attach a channel update. So the errors we have today are bad onion. You just can't read what's in the onion that is attached to an HTLC. You have permanent failures. It's never going to work. You have node failures. The node that is trying to relay the payment is having problems. And you have update failures. So it's almost right, but for example, you're using fees that are wrong because you probably have a view of the network that is outdated. The channel update you used to compute the route is too old and does not reflect the latest fees that have been set by the node you're trying to relay the payment through. So when you have, for some types of errors, the payment has failed and you need to compute a new route and try again. For some type of errors, like update errors, you can actually keep the route you have, apply the new update, so just change the fees you're paying along the route and try again. And you can ban channels for a short while when you have temporary errors, or you can just remove channels from your local view of the network when you have permanent errors. But this has an impact on UX because every time you retry, it takes a few seconds basically to compute a new route and retry the payment. So if your view of the routing table is too old, too outdated, you will get new information as it fails, but it's really bad UX. So there's a compromise to be found between synchronizing everything when you start your Lightning node and having a good enough routing table so that you can start attempting to pay, but failing because your updates are too old. And that's what we'll see tomorrow. Is it tomorrow or in 2 days? When we talk about gossip, how do you efficiently synchronize routing tables? How do you make sure that you have enough information to find routes and that the route you compute is good enough so that your payments will go through and you will not have to retry? And for some if you've been using Eclair, for example, a few months ago, we would attempt to pay even if the routing table was not really synchronized, and you would see that the first payments, very often users would complain that the first payment was slow. It looks slow, it takes a few seconds, and then it's quicker. It's because we're trying to update the routing table and we would often fail the first payments, get the updates we needed, and try again with the new updates. So it's something you can see with some Lightning wallets, and it's bad UX. So we've pushed really hard for changes in the specs to make routing sync more efficient, because if you use outdated data, you pay the price from a UX point of view. Your payments are slow, and that's not too good. The idea is, for a good mobile wallet, you open your wallet and you want to be able to pay within a few seconds. If it takes more than that, it's bad UX. So that's why I think a good view of the network is very important, especially for end users. And that's why we're going to talk about how to efficiently synchronize routing tables. There's something that was, I think, not mentioned by Alex when it comes to incentives. But if you look at this, what do you think the node in the middle needs to know about the network? What kind of routing table does it need to have to forward payments? Does it need to have good information on the network to be able to forward payments? It doesn't need anything. Right now we have a strange situation where the big nodes, like in the middle of the network, that do all the relaying stuff, they don't really have an incentive to have good routing tables because they don't use them. The only ones who really need a good routing table are the end users, and they're in many ways the weakest nodes in the network. They run on phones that are offline very often, on small devices with less CPU and less memory, and they're the only ones who actually need routing table. The node in the middle, it doesn't need anything, which is why Trampoline is changing this. With Trampoline, you do, if you're a Trampoline node, you do need at least a partial view of the routing table. So the incentive, I think, are in a way fixed by Trampoline, because for this to work, even relaying nodes will need to have at least a partial view of the network that is up to date. And that's not the case today.
Is there any scoring actually implemented in Eclair or Lightning?
I wouldn't say there's scoring, but I'm pretty sure that every implementation is looking at ways to ban peers that misbehave. Like we've become more and more aggressive. Like if you send us updates for channels that are being closed, after a while we will ban you. But I guess it's
But scoring with navigation of your uptime and
okay.
how
So,
much we're going to
yes,
score.
I mean, all of us use a scoring of a certain kind. It's just the type of signal that we mix into that score that changes.
Yeah.
So we are currently using the CLTV deltas because that's a time money might be locked up, and the fees as a signal into a score. And I guess you are also using the same signals.
Yes.
And we can add additional signals. That's
because
not
you
an
have-
issue.
In this score is used both to drive the autopilot and both how you are going to build the route, or
We don't have a autopilot per se yet, so we use it mostly for choosing a route or prioritizing one channel over another.
Yes, we do the same. We have heuristics to try. Basically, if possible, we try to use to find a route that is the least expensive as possible for you. But we try to use the oldest channel and the ones with the biggest balance or biggest capacity. Sorry, and with the smallest CLTV delta. But they're just heuristics. But what you're saying, I think, is a bit different. Every Explorer now, every Lightning Explorer is trying to push their own ranking system, which can be heavily game, and basically that's a different story. But that's what BitFury was trying to do with Lightning Peach, and 1ML also has ranking information. I think others too, but how it's computed is not really open yet.
oh yeah.
And
I was more thinking that, maybe having more signals and letting each node doing its own algorithm or doing its own composition to drive its own policy.
I think what you do locally to ban peers that misbehave, like for example, you could do probing. I think C Lightning does that now.
Oh, we have plugins that do that.
So
we
you
don't have
probing, basically you create payments with a random payment hash, and it's supposed to fail right away. If it doesn't fail, it means something's wrong, and eventually someone will detect that nothing is coming back, and after a while you will close channels, because having channels that are not efficient is a waste of money. Basically,
Yeah,
you're
it's a
looking-
waste of capital.
So we believe that as the network grows and channels become bigger, nodes will start be more aggressive when it comes to banning misbehaving peers and closing channels that are not used or that are not efficient. Not maybe not blacklisting, but if you have a channel that is never used, you will close it. And if every channel where every payment attempt fails, you will close it. And we have we run a fairly big node on mainnet, one of the biggest, and we have started being fairly aggressive when it comes to channels that are not efficient or not used, because it's a waste of everything. It's a waste of money for us, and it's bad for everyone because it makes payments not reliable. But I would say also that you don't want to have only public channels. If suppose mobile phones are all private channels, you would like to have mobile phones connect to you because mobile users will mostly pay.
You sell them a service. I have a nice floating nodes and all enable. Yeah. There's maybe a asymmetric incentive between. As a mobile phone, I want all my channels to be private, but you, as a routing node, you want to be connected to this phone, right?
You want to be as reliable as possible,
Yeah.
so that people will want to connect to you because they know that if they try to pay through you, it will work.
Yeah. Yeah, but you may, try to open a channel with them, so it's great for them an incentive to use to route payments through you, right? You're giving them a discount opening, or I don't know.
Not today, no.
Yeah. No. Sure, it's not something implemented today, but maybe far in the future.
There are enough channels and nodes with zero fees today. I don't think we're gonna add more.
Sure.